All right, final round for today. Um, we're gonna talk a little bit more in depth about programming and compilation. Um, this first bit is going to be the levels of language. The picture on you right. Yep, the picture on the right is actually of some assembly that was taken from the Xcode programming environment on Mac OS X. Um, assembly is one of the three pieces that I'm going to talk about here. Um, machine language being the first piece that we've mentioned several times previous. That's the ones and zeros. That's what your processor can actually understand in order to get things done. Assembly language, as you can see on the right, is a sort of short, simple codes that translate directly to machine language. And they can vary from processor to processor. Depending on what you're dealing with, for the most part, you'll find the same commands for assembly, but they might have different names across processors, and that's where the big problems come in. And there may be other features that are available on a processor that do different things easier than another processor, but we won't get into that too much. And then there's high-level language, which is the language that we're going to be dealing with, the languages that we're going to be dealing with for the most part. These languages are designed to bring programming closer to what we can understand. And there's been a lot of work in recent years to create another set of languages called fourth-generation languages, which bring us even closer to that sort of human English, human language understanding of how to write code to make it a little bit easier for people.
Like that animation jump, it can be coded down.
Kind of. It's not that far along yet.
Well, yeah, no, but is that what they're trying to achieve?
Yeah, I mean, like, for an example, one of the languages that I deal with fairly regularly is called SQL. It's structured query language. It's a mechanism by which you can grab information from a database. And so I can say things like, select all from this table, whatever the name of the table is, where this particular value is equal to this. And it will produce a result for me. It's things like that's about the point that we're currently at. A lot of people are still dealing with the third generation high level language sort of deal where it's sort of pseudo English and it makes sense to the programmer, but if you hand it to an English major, they're going to be like, excuse me. So, and there are a lot of different high level languages. This is a very short list. These were the ones that I could fit on the slide, just thinking off the top of my head. Java, C and C++, Python, Lua, C#, VB.NET, HTML5, CSS3, JavaScript, and there are others, Ruby, Perl, PHP, Go, Erlang, Haskell, what's another one that I could pull? Objective-C, Cocoa, Touch, and Swift, which are all Apple. Groovy. Groovy's another one. Kotlin. And I'm running out.
The different languages just so that they could segregate each of the.
These languages are created in an attempt to meet a task more efficiently. Like Java and Python tackle the issue of running across multiple different operating systems without having to write different code, which C++ is not very good at. which was what a lot of programs were written in back then, when Java first came around, and I think Python came sometime after. Um, certain languages are specific to certain operating systems. VB.NET is specific to Windows, and I believe C# is as well. Both Cocoa Touch and Swift are specific to Apple. HTML5, CSS3, JavaScript, and PHP are all conventionally web programming languages. Oh, I remembered another one, ASP.NET. That's another web programming one. So there are a wide variety of reasons why you would use one language or another. And at some point or another, when we hit the robot programming stuff, we'll talk about why there are, oh, LabVIEW, another big one. We'll talk about why when we get to the robot programming stuff, why specifically FIRST and WPI chose the 3 languages that they did, that they allow robotics teams to program in for the competition. But like, just as an offhand example, I know how to program in Lua. The only time I use Lua is when I'm doing projects in Minecraft with the ComputerCraft mod. That's literally all I use it for.
You still do that?
From time to time. It's not anything that I use outside of Minecraft. If I had to use it for something now, I'd have to spend a little bit of time brushing up on it. But for the most part, every language has its sort of niche area. But moving on from that, we're gonna talk a bit about a specific type of programming language, and that's called an object-oriented language, which is what Java is. Now, there's really 2 big camps, let's say, of languages. There's functional programming, or scripted programming, let's say, and object-oriented programming. Object-oriented programming is the idea that we can represent real-world objects in programming. So if we wanted to have an object that was, let's take a refrigerator in, for example, we could have a particular value that represents the wattage draw of that particular refrigerator. We could have a particular value that represents whether or not it needs to have its Freon refilled. We could have a particular value that represents whether or not the fridge door light is on. And then we could also have specific actions that the refrigerator could perform, like turning the compressor on, turning the fans on, and turning them off. We could have turn the light on, turn the light off. We could have dispense ice and water if you have a newer fridge. And even some fridges, much to my confusion, also have computers built into them now, which can do things like access the internet, show you recipes, play Pandora. Why you would need a computer in your refrigerator is beyond me, but
Climate control inside the refrigerator.
yeah, I mean, maybe.
Cold is cold.
But that being said, we call the characteristics that I mentioned things like whether or not the light is on or off, whether or not the compressor is running, whether or not it needs more Freon. We call those characteristics of an object instance variables in programming, because we can have multiple instances of the same object. It wouldn't make any sense if you could only have one refrigerator. Let's say you're designing some sort of synthetic restaurant environment inside like a game or something. Most restaurants don't have one refrigerator, so that wouldn't make any sense if you could only have one refrigerator. So each object has its own set of instance variables that you can fill out with specific information, and that can change, independent of the other objects that have been created of that same type. The other thing, behaviors and actions, are things like turning the compressor on and off, turning the light on and off, dispensing ice, dispensing water. These are known in programming as methods, specific actions that an object can take in order to perform some task. Obviously, with the fridge stuff, it'd be fairly menial.
Is that with like the if-else statements coming?
No. That's called a conditional. That's week 2 or 3. I can't remember now. But we'll get there. The whole idea of this is that we need to be able to create a template of an object, and then we need to be able to create multiple instances of that object at any given time so that we can use them throughout our program. And this is probably the most confusing part out of the day. So does that make sense?
So like how we did the integer values for something.
We'll get there. This is probably not the. It's probably not. It's not as easy to see it. I mean, it's easier to see it than it is to hear it. Object-oriented programming is one of those things that it can be very difficult to grasp initially because most people don't think about computers as being able to represent real-world objects. They think of computers conventionally as being able to make decisions in real time and crunch numbers and display text. They don't really think about how, a Word document that you open in Word might actually be represented by a class called document that is represented specifically by a document that stores text and information like the number of words, the number of characters, the actual formatting type that the text is stored in, like UTF-8, UTF-16, ASCII, what have you. So we will get there. It will become clearer as we move along. Object-oriented programming comes towards the end of Book 0, simply because we have to have more pieces so that we can actually do stuff with the objects once we get there. But once you have a grasp of object-oriented programming, there's a lot of really cool stuff that you can do that is extremely difficult to do in a functional, scripted style language, which is devoid of representations of objects and is much more like what people would classically think a programming language would be like. Moving on, we're going to talk a little bit about the compilation of languages. Obviously, I've mentioned several times already that computers can't interpret language like we do. It has to be ones or zeros. So we have to get from point A to point B, and somewhere in the middle, someone has to do some work in order to take what we wrote and make it something that the computer can understand. This is where your compiler comes into play. A compiler is a computer software program that takes what you wrote, that you understand, and makes it that binary information that a computer can go and read and execute on the processor. Now, every language has a slightly different and sometimes drastically different way of compiling code. But in general, it all comes down towards the same direction. Some compilers are more efficient than others, just as some programming languages are more efficient than others. But in general, programming languages themselves all follow the same format. They're taking something that you wrote, compiling it, bringing it down to binary, and then the computer can execute it from there. One of the bigger exceptions to this is actually Java. Java had to be a special snowflake and do its own thing, which is what we're going to talk about for our last slide for the day. Java does something a little bit different. Every Java program runs in something called the Java Virtual Machine. The JVM acts as sort of a bridge between the compiled stuff that you wrote and the actual operating system and the processor that you're using. With a standard program, like a program written in C and C++ that's supposed to span operating systems and processor architectures, you have to have the programmer themselves write in the pieces that differentiate what needs to happen for a specific operating system or a specific processor. And that takes time. A lot of time, usually. Java sort of does a cheeky trick in that what they do is they compile what you write down to something called Java bytecode. And Java bytecode is sort of like middleman machine code. Basically, it takes it and makes it something that the JVM can understand, and then the JVM takes it and makes it something that your specific computer can understand. So the people that actually maintain Java, which is Oracle, they write the JVM and the libraries that run on top of the JVM, so that way that they run on different machines and different operating systems. And then you write the code that runs on top of what they wrote. You don't have to know what's going on in the JVM in order for your code to work, because Oracle's already done that for you. It will just automatically take what you wrote and say, okay, for this operating system, I need to convert it into this, this, and this, and this. And for this operating system, it needs to be that, 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 and that. And for this other operating system over here, it needs to be something else, something else, something else, without you having to do any accessory writing of code or anything like that. You still have the option to do that in Java. You can still write code based off of what operating system you're using. But it's somewhat frowned upon simply because of the way Java is written, and it's designed to make it so that code doesn't have to be changed so it can be run on more operating systems or more processor architectures. All someone needs to do is go out and write a JVM for that particular scenario.
So basically, Java's starting the conversation and you're finishing it.
Right. So, any questions before we say we're done for the day? Doesn't seem like it. So what I'll do is the link for the test for this week will be in the comments of each video that I post for this week. For those of you here, if you'd like to take the test while you're here in the last half an hour, you're more than welcome to. I guarantee that I won't be able to grade it before you leave, because only some of the test is auto-graded and the other stuff I have to look at myself, just because some of it is text fields, which means that there's no real way for me to, in Google Forms, to actually set rules that would say, oh, if it's all lowercase, it's fine, or, oh, they missed a letter here, but I know what they were trying to write, that's fine. So I have to go in and actually look. But that being said, next week, whoever shows up, I will have your test with me. I'll have a copy of everybody's test with me along with their grade. And for those of you who don't show up next week for whatever reason, you had a prior commitment, what have you, I will either hold on to it or I will email it to you. I am considering at this point probably just holding on to it, because for some people, the only point of contact that I have is their school email. And I don't know about you guys, but when I was in high school, I never used my school email. I mean, it was forwarded to my regular email, but it was forwarded to a folder that I didn't look at. So, I'm not really so much comfortable with using some of the emails that I've gotten. But if you want to know your grade, you can obviously always reach out to me, and if I haven't graded it yet, then I'll tell you I haven't graded it yet. But if I have, then fine, I'll give you your grade from whatever mechanism that you send it to me in. So, that being said, this video is done. I hope that more of you can attend next week in person. But if not, just watch the videos next week.